Today we are going towards latest paper of physics, paper 1, variant 2, with the code 9702 over there. And this is Cambridge International ACE A-level and physics paper 1, variant 2, which is related to 40 multiple choice questions. And May, June 2025. Overall, if I talk about the syllabus and the contents which were mostly highlighted into the exam questions, I will say he has given the easiest part of physical quantities over there. He has given the easiest part, physical quantities. Easiest part was given, not too much fractional uncertainties or percentage precision or accuracy was too much strong over there. But I will prefer here that he has given energy questions, he has given dynamics properly, he has to resolve that components into properly point of view over there. Electricity, pressure, everything was included over there. Pressure, electricity, elasticity, deformation was too much easy over there. Electricity. And if I talk overall paper was very easy. Overall paper was easy, very easy, was very easy, but little bit confusing according to statement reasonings over there. And if you will watch the whole paper video for today, inshallah, you will feel that it was a conceptual paper overall. And kindly, it is a request that kindly subscribe my channel after watching the complete video, and it will be much supportive according to your preparation over there. Okay, this is our paper, May, June 2025, and 1 hour 25 minutes is the total time over there. May, June 2025, latest paper, 1 hour 15 minutes time. 9702 is the code, and paper 1, variant 2 over there. Let's go towards our questions, and there are total 40 questions available, and every question is having 1 mark over there. Okay, let's move to question number 1 over there. Let's see what he is saying in the question number 1 there. Here he is saying that what must be in all quantities should be present, have. What must all quantities should have? A direction and magnitude is related to vectors only. It means scalar is not included as like physical quantities, so it will not be the right option. Direction and uniting, meaningless. It means there is no meaning over there. Meaningless over there. Magnitude and prefix also is not any quantity being derived. Magnitude and unit will be placed by both scalar and vector over there. So this is the right option for this question over there. After that, he is saying in the question number 2, what is this? Expressed in Newton per meter square. So here it is millimeter square, here it is kilo. So I will have to remove these prefixes over there. 0.25 multiply by, for removing this kilo, I will write here 1000, and then I will say go with millimeter square. So millimeter per millimeter square. So it is to be taking with the denominator coming upward with the 6 zeros, one with 1, 2, 3, 4, 5, and 6 zeros over there. So for removing this, I will say here that 6 zeros these and 1 this 0 I am joining in the form of 8 zeros, 7 zeros, when these 2 zeros are going towards 25. So 25 with the 7 zeros will be taken as the right option over there for converting this prefixes over there. After that, this is related to fractional uncertainty in the form of percentage uncertainty to be taken into account over there. Okay, a student calculates the density of a solid steel cube in an experiment. Okay, the measured mass is 975. Okay, so mass in gram over volume will be taken to calculate the density over there. So mass is 975, and he is saying that it is in per cm cube for every case. So I will have to convert this 50 millimeter one length into centimeter, that is 5 centimeter. So 5 multiply 5 multiply 5, it is giving 975 divided by 125. And in all cases are present 7.8, 7.8, 7.8, which will be obtained from here. After that, the second case is I will have to go for fractional uncertainties. For that case, I know that it is least count divided by its main value, 10 over 975 multiplied by 100. You are getting here your percentage fractional uncertainty for mass over there. Let's go for its calculation over there. Then he is saying that we are going to do 10 over 975, mean 1000 over 975. 1000 divided by 975, it's equal to 1. So I am saying it is 1. And for the second one, if I observe here, it is 1 divided by 50. 1 divided by 50 multiplied by 100. So it is for length percentage uncertainty over there. Then for this case 50, it is 2% and 2% over there. For that purpose, then I will say I know that the volume is length multiply length multiply length. So power should be multiplied with this percentage. So 3 multiplied by 2 is equal to 6% should be taken into account. Then adding this 6% and this 1%, total 7% is there. So it is option B is right for this one. I think so now it is clear according to your point of view for this question. After that, he is saying here, the time period of a pendulum is given by t is equal to 2 pi n power n L over G. So for this one, if I say length is measured is a length, its unit is meter, and it is measured as acceleration, its unit is meter per second square. So it is meter over meter per second square, and pi and 2 are constants, so just ignore them, and t is taken in the form of second over there whole power n. From here meter and meter is cancelled over there, and the remaining is s minus 2 is coming upward, that is s square. How much I should take n over there to get s? So n should be 1 by 2 over there, so that 2 and 2 are going to cancel out and s become equal to s over there. This is the way how to check the homogeneity of the equation. The equation is homogeneous. We can calculate by using the units by getting this value. Let's move to the next question over here. Here he is saying that radio wave can be used to measure the distance between Earth and the planet Jupiter. All right. A pulse of radio wave is emitted from the surface of Earth. The pulse reflects from the surface. So it means this is Earth, this is Jupiter. Light is going towards Jupiter, radio wave, and coming back. It means it is traveling the distance for 2 times over there. And the time between the emitting and receiving the pulse is 3960. What is the distance between the Earth and the Jupiter? All right. So I will have to go S is equal to V multiply T. And this is the distance for 2 times. So I will have to divide it by 2. Then I will write it 3 multiply 10 is to power 8 multiply 3960 divided by 2. Let's go for calculation over there. Here he is saying 3 multiply 3960 multiply divided by 2 equals to 5940. So it is 5940 multiply 10 raised to power 8. So I will have to look here. Oh, that's nice. He has converted it into kilometer. And it means I will have to take my decimal from here to here. So it is 5.94 multiplied 10 raised to power 8 kilometer for this question will be the answer there. After that, he is saying the graph shows the variation with the time. The velocity time graph is given. Which statement is correct? The car accelerates 2 seconds and then stops for 4 seconds. No, it is not stopping. It is going with constant velocity after 2 seconds over there. The car accelerates 12 meter per second square for 2 seconds. 2 second, no, it is 12 minus 0 over 2 minus 0. Then acceleration is 6 meter per second square. It is not 12 meter per second square. The car travels a distance of 36 meter. Okay, for 4 seconds. So it is looking just like a trapezium over here. Sum of parallel sides, I have to take 4 plus 2, that is 6. And then I can say height is being taken as in the form of 12 into 1 by 2 to 6 times 6, 6 times 36. So 36 meter area under graph should be taken. So this statement is correct. No need to go for the fourth one. Okay. After that, here he is saying an object, a solid object of mass 1 kg falls freely downward in the vacuum. All right, this is the mass object moving with the help of 1 kg mass over there. If I take under gravity, I say it is 10 Newton, approximately like that. Okay, when the speed is 60 meter per second, 60 meter per second, what happens? Force of 50 Newton is coming up. 50 Newton is coming there. Okay. Now, what should I go to say over there? He is saying, what is the speed after 2 seconds there and additional force over there? All right. So from here, I can say it is 50 and 10 is going to subtract. It means 40. And I'm not taking Newton because 1 kg is the mass over there. So I will say acceleration is 40 meter per second. That should be multiplied by 1 kg over there. So 40 is my acceleration here. In the form of, because it is going in upward direction like that, if I take under the gravity over there, vertically upward and downward over there, then I can say it is negative acceleration. On the other end, if v is I want to calculate, minus u is 60 over 2 should be taken over there. So from here we can say it is being taken as minus 80 plus 60. So my speed is 20 meter per second. And this negative sign can be ignored because we can say we are talking about speed over there. We are not talking about velocity over there. So it should be like this. Okay. Here he is saying a stone is thrown vertically upward over there. All right. And follows a curved path. Wait a second. Wait a second. Okay, a stone is thrown upward and the following curved path. Here resistance is negligible over there. And why does the path have this shape? The stone has constant horizontal acceleration? No. It has constant vertical velocity? No. Both cases are written oppositely, like totally opposite happens over there. The stone has a constant horizontal velocity. It's fine now with the velocity, constant horizontal component, which gives the range over there in projectile motion, and a constant vertical acceleration over there. Yeah, it's fine. Vertical acceleration is under gravity, that can be 9.81 while going with the downward, and when going upward, then it should be taken as negative over there. So this is the way for solving this question over there. Now he is saying a rocket engine ejects 90 kg of exhaust gas per second at a velocity of 190 meter per second relative to the rocket. What is the force acting on the rocket due to ejected gas over there? Okay, here I am using, because I want to calculate the force, I am given with the mass and velocity over there. Then I'm taking momentum and force relationship. F is equal to mv over t, and mass over time he said 90 kg per second. So I can take it 90 multiply 190. So it should go with 90 multiplied by 190. Okay, it is 17,100. So it is 17,100, which is approximately equal to 17,000, which is equal to 17 kilonewton. It should be taken like this. After that, he is saying which statement does not describe. Okay. The relative speed approach of two objects equals to relative speed of separation. He is correct. The total kinetic energy remains conserved. Correct. Total kinetic energy of the object is reduced. No. So not describe is verified by this option. After that, he is saying a cyclist riding at a constant speed on a level road, according to Newton's third law of motion, what is equal to the opposite and backward push of the backward wheel to the road? Okay, action reaction should be involved over there. And let's check. It is the force exerted by the cyclist on the pedal. No. The forward push of the road on the pedal. Okay, fine. It is correct because action and reaction are equal in magnitude and opposite in direction over there. After that, a stone is released from rest and falls along a long distance in air. Which graph shows the variation of the time? In the start, because body is at rest, released from a rest, and from a long distance in air, means initially its acceleration will be maximum. So this cannot be taken and this cannot be taken as a constant over there. Initially, it will be strong. It can't be straight because as the speed is increasing, upthrust is increasing. So option D will be fine for it. As I said, acceleration is going towards gravitational acceleration, and then upthrust is also working on it. So when acceleration is going to increase and its upthrust force is getting equal to its weight over there, then overall terminal velocity will be attained, and that terminal velocity shows that the acceleration is equal to 0 over there. So we can say it is approaching towards 0 over here vertically to show the acceleration value over there. Okay, let's move towards next one. An empty cart is moving along a horizontal track at constant velocity. Resistive forces acting on the cart are negligible. A heavy rock is dropped vertically into the cart. Okay, it means empty moving cart is present with constant velocity, and a heavy rock is dropped vertically into the cart. Now he is asking if it is dropped into the cart, what will happen according to this relation over there. Okay, the cart with the rock inside has smaller momentum. No, same momentum. It should have same momentum and smaller kinetic energy. Same kinetic energy. Smaller kinetic energy is fine. Smaller momentum, no. Same kinetic energy, not possible. Same momentum, same smaller kinetic energy. So it should have this option, right? According to the law of conservation of momentum and law of conservation of energy. Momentum and energy over there. Okay. Here he is saying a wooden block is held stationary in a container of water using a string attached to both wooden block. This is the wooden block, okay. And bottom of the container, it is attached through a string, all right. The wooden block M has mass M and volume V, all right. The water has a density rho over there. The acceleration of free fall is G. What is the magnitude of the force acting on the block due to the tension? Okay. So upthrust is acting, that is, if I say pressure is equal to force over area, then force is equal to pressure into area. Pressure in liquids we know is rho g h into A is happening. This is equal to rho g v. This was the total upthrust. But the tension is also being involved the weight of this object, so it should be subtracted with mg. Let's check which is this option according to this statement. Yeah, this one, option D, is fine for it. Like this is the upthrust, just subtract weight from it, then you will get the tension in the string over there. Okay, after he is saying a square shop sign of uniformly density has mass of 2.4 kg and sides of length 0.86 meter. The sign is supported by a hinge along its top edge. Okay, here it is hinge and it is supported. All right. Then it is vibrating here and here. All right. It should be also being taken for this one for getting balance over there. There is a friction in the hinge. So the sign that hangs from it equilibrium is 15-degree angle over there. All right. To the vertical sign shown. What should I go for it? What is the moment about the hinge of the weight of the sign over there? Okay. Then we should take mg sine of theta as a vertical component in front of this. And I will take this theta as 15 over there because I can take it double over there also because I need for 15. But the angle value will be coming here. Then for that one, I will divide it by 2. And the distance, force into distance, or perpendicular distance, that is 0.86 over there. And for this values is what is for mass? Mass is value 2.4. Okay. 2.4 into 9.81 into sine 15 degree into 0.86 divided by 2 there. All right. First of all, let's go for sine 15 over there. 15 sine. That is 0.25. 0.26. Let's take 0.26. 0.26 multiply 9.81. 9.81 multiply 2.4. 2.4 multiply 0.86 equals to this divided by 2 there equals to 2.6. So it is option A is fine for it. Let's move to the next. Okay. Here he is saying a block is submerged vertically in the liquid. Okay. And the 4 diagrams of the block viewed on all sides, which diagram shows to scale the forces exerted on equal areas of the block by the liquid over there. Equal areas by the liquid over there. So if I observe here, equal areas over there. If I say this one is already gone, equal areas, so it is not equal over there because the sizes, if we observe on both sides over there, are going to be shown that the forces are exerting on equal areas but not are uniform little bit over there. This is also unequal, so option A should be gone for this, that all the sides are given with the equal force exerted in on equal areas of the blocks over there. If we just look at this area, then we can say it is properly implemented over there. Okay, this is the simple couple definition question over there, where he is saying the diagram shows force is given, and this is the perpendicular distance over there. How is the torque of a couple is calculated? then the formula is perpendicular distance multiplied this force over there only. So perpendicular distance between, it is going to do 1/2. No, perpendicular distance between the force and magnitude of one force. So it is right. Sum of forces is not right. 2 multiply perpendicular distance is not right. So option B is fine for it. After that, he is saying 1.2 kg travels horizontally with the speed this. Okay, the ball hits the cushion and comes to rest over a horizontal distance of 0.020 meter. What is the work done by the... So it is simply kinetic energy over there. So I'm saying 1.2 multiply 1/2 into mass into speed square is 9. 4.5 multiply 1/2. So we can take it 4.5 multiply 5. I take 4.5. 2 is dividing this 9 to 4.5. 4.5 multiply 1.2. 4.5 multiply 1.2 over there is equal to 5.4 joules. That is option C over there. Let's move to the next question. Okay. Okay, here he is saying that first go with this. A box of mass 4.9 kg is pushed at a constant velocity at point P at the bottom, okay, towards point Q. The box is pushed by a force of 64 Newton. So for calculating the applied work done energy, I will have to go for 64 and to take this inclined distance over there. All right. For this inclined distance, I should go sine 20 degree is equal to, let's see, it is PQ will be coming down and perpendicular is 5.8 over there. So PQ is equal to 5.8 over sine 20 degree. All right. 5.8 divided by sine 20. So I'm taking sine 20 first. 20 sine 0.34. Okay. 5.8 divided by 0.34. 5.8 divide 0.34 equals to 17.05. Okay. 17.05. 17.05 should be taken. Then I can say here 17.05. 17. Okay. Then if this distance is 17 over there. 17 meters should be multiplied with 64. Then force into distance will give me the work over there. Then I will take it in the form of 17 multiplied by 64 should be taken as total work done energy over there. And then I will take my useful output energy here. That will give me mgh. That is 4.9 into 9.81 into 5.8. All right. Then I will subtract both of them. Fine. So 17 multiply by 64 equals to 1091. So it is 1091. 4.9 multiply, okay, 4.9 multiply 9.81 multiply 5.28. 5.8 multiply 5.8 over there equals to 278.8. 278.8 over there. Just subtract both of these values, 1091 and 278, and it will give us 1091 1091 minus 278.8 equals to, so 8128 is, so it is 812 approximately equal to 810 over there. 812 approximately equal to 810 joules over there. This was a little bit tricky, but we should go for it. Which expression gives the efficiency of a system? All right. Which expression gives the efficiency? So according to definition, when we are saying which expression gives the efficiency, output over input. So useful output energy over total energy input is the right option over here. Total energy input, no. Total useful energy plus waste energy, Y, and wasted energy not required. After that, here he is saying the student has a copper wire and a steel wire with equal lengths of cross-sectional area. Okay. The student hangs identical loads also. So stress is equal to force as load over area. So this can be sent. So the student calculates the stress, strain, and Young's modulus and identifies the tick calculated values are equal of both wires. Which values can be equal? That can be only stress because strain is involving the length. Young's modulus completely also involving the strain over there. This will involving strain. This will involving the strain. So only stress is that load is the same, area is the same, and stress can be different. Stress can be equal. Remaining all will be showing the variable values over there. All right. After that, he is saying that two springs, X and Y, stretch elastically. The graph shows the variation of extension X and force F over there applied on each spring. Okay. Here, which statement is correct? When each spring is given the same extension, the energy of Y is 4 times the energy of stored in X. Okay, let's measure the energy over here and then here. If I take 10 into 20, he is saying same extension. So if I'm taking 10 here, I will go for 10 here also, but 5 I can go here and it can get 5 here as like this. So it will be 10 at that point value. So it will be 50 and it will be 5 into 80, 400, 5 into the 40, 400. Okay. And it should be divided by 2 also. It is 200 and it is 2 is giving 25. Why I divided? Because I know that force into extension graph giving the energy value by area under graph, and area is 1 by 2 into base into height over there. And because it is a right angled triangle are being formed over there. So it is not 4 times, it is approximately 8 times over there, which if spring is given the same extension, the energy stored in Y, this is spring Y, is 8 times and the energy stored in spring X over there. So option B is fine for it. Which phrases describe the strain of the elastic limit on stress strain graph over there? So the maximum strain below which Hooke's law is obeyed? No. Below which Hooke's law is that is not maximum strain over there. It can be go for plasticity over there also. Maximum strain below which deformation is plastic. No, the minimum strain Hooke's law is obeyed. The minimum strain which deformation is plastic. Fine. Option D is fine according to plasticity, elasticity, and basic elastic spring quantities or qualities over there. A teacher removes the turntable from a microwave oven and places a bar of chocolate in the oven. She then switches the oven on for a short time. A stationary wave is formed in the oven. Okay. When chocolate is removed, the teacher observes that there are two small sections are melted. Two small sections are melted. Okay. In the form of this, and this. Two small sections are melted between two small sections of melted chocolate 6 centimeter apart with the unmelted chocolate in between. Unmelted chocolate is in between over there. Each section is melted chocolate is located as antinode. It is antinode over there. Okay. Two sections melted. Okay. It is total 6 centimeter over there. All right. Then he's saying as the speed of microwave oven is this, find what is the frequency for it. Okay. So I will take the formula is NV over 4L. N is 2 for it. V is 3 multiplied 10 is to power 8 divided by 4 into 0.06. Let's go for it. All right, calculator. Okay. 2 multiply 3, 6 divided by 4, 6 the 24. 6 divided by 0.24. 6 divided by 6 divided by 0.24 equals to 25. Multiply 10 raised to power 8. All right, it is option C over there. Okay. 25 multiplied 10 is to power 8. 25 multiplied 10 is to power 8. If I go for 2.5 multiplied 10 is to power 9, then I will get answer C over there as my whole value over there. Okay. Let's move to the next question over there. Here he is saying that a sound wave travels from the left to right. The graph shows the variation of the displacement to the right particles in the sound wave with distance at one instant. Which letter represents the center of compression? Center of compression. It is moving from left to right. From left to right, the graph shows a variation of the displacement to the right particles in the sound wave with distance in one instant, at one instant. And which letter is that? Will be option B over there to show the compression over there. This is showing compression of the particles for sound wave will be shown over there because it is moving from the displacement to the right over there, not to the left. If it is moving towards left, then I say it is D over there. But right now it should go with the B over there. Okay, now he is saying a buzzer emitting sound of frequency 840 hertz is attached to a string, is rotated in a horizontal circle. The linear speed of the buzzer is 25 meter per second. Okay. The speed of sound is 340 meter per second. What is the maximum frequency of the observer? So, as we know, frequency of observer is equal to frequency of source into speed of source, 340 over 340 minus 25 over there. So let's go with it. Fs is 846. It should be 846. 846 multiply 340. 846 multiply 340 divided by 315. 315 is equal to 913 hertz over there. So it is this formula. Here I use the simple formula of Doppler effect over there. So remember that when you are getting the maximum frequency, then subtract this. Otherwise, add this value with getting the minimum frequency in that case. Okay, here he is saying that vertically polarized light of I naught Okay, is incident normally on a polarizing filter. The transmission axis of the filter is at an angle of theta, okay, to the plane of polarization of the light. The intensity of the light after passing through is I naught over 3. Okay, we know the molasses law is equal to I is equal to I naught cos square of theta. After that, I have I naught over 3 over I naught square root as cos theta. So it is going towards cos inverse 1 over under root 3. So cos inverse 1 over under root 3 should be taken for theta angle. Let's go for it. Cos inverse, how I will go for more cos inverse. Okay, this is cos inverse. All right. So I'm saying 1 divide under root 3. Under root 3. Under root. Wait a second. It is going to make me confusing over there. 1 divide under root 3. First of all, I'm taking under root 3 over there. Under root 3 is equal to. What is this? Under root 3 equals to. So he is saying, okay, square root is cancelled. So he's giving me 3. Okay. I'm saying, wait, I'm taking it, the other calculator over there. Calculator square. Maybe it will help me. Okay. 1 divide under root 3 equals to 1.73. Okay, I will have to divide this answer over there. 1 divided by 1.73. 1 divided by 1.73 equals to 0.578. Okay, 0.578. Now cos inverse 0.578. 0.578 equals to 54.6. Okay, 54.6. So it is 55. Option B is going for it. 54.6 approximately equal to 57 degree over there. Okay, now question number 28 over there, where he is saying which statement compares the behavior of transverse and longitudinal waves. Only longitudinal waves can be diffracted. Now, only longitudinal waves can travel in free space. No way. Only transverse waves can be coherent. No. Only transverse waves can be polarized. He is light. According to Molasses law, only I can polarize the transverse light or waves over there. According to Molasses law, I have explained to you. A student uses a diffraction grating to determine the wavelength of visible light from source. The diffraction grating is 300 lines per millimeter. Okay. And the student measures the angle theta of an order n and intensity of maxima. The graph of n against sine theta is drawn as a straight line. The best fit line of is placed over there. Okay. If I go for its complete working over there, then I'd say 1 millimeter, 300 lines per millimeter means 300 lines divided by per millimeter, multiply 10 raised to power minus 3, 300 lines per millimeter. And what he said, student definition theta and intensity of maxima is being taken. Okay. So 1 over 300. If I take one line for that 100, then because I need the gradient over here, so I will say here 1 divided by 300 multiply 10 raised to power minus 3 1 by 3, 0.33, 3.3 multiplied 10 raised to a minus 3. Minus 3 should also be added here. So it is 3.3 multiplied 10 raised to a minus 6 divided by gradient will give me the value of wavelength over there. Okay, this is the simplest calculation how to go for it. So it is going towards 3.3 multiplied 10 to the minus 6 divided by the gradient of visible light in terms of G over there. And he said that it has the gradient G. Okay. Okay, wavelength is being taken over there. Two waves meet, which is not necessary condition for the waves to produce a stationary wave over there. Okay, which is not necessary. They must have the same type. They must have the same period. They must have the same wavelength. They must travel in opposite direction. This is not necessary. Okay, light from a signal. Okay, light of a signal, a single wavelength is incident normally on a double slit. Okay, interference of the fringes are observed on screen. The distance from the double slit of the screen is okay. I will have to go for slit separation. Lambda is equal to AX over D. So slit separation is X over here. Lambda is where it is given light signal of the wavelength of a single wavelength is incident on this light. Interference of fringes observed. The distance between the slit and the screen is slit and the screen 0.6. So denominator is 0.6. After that, fringe separation is 1.8 millimeter. 1.8 multiplied 10 is to a minus 3. After that, I will have to go for the distance from the double slit and the screen is double slit and the screen is increases by 0.90 meter. Lambda and A is going to increase. So this is going to increases by 0.90. So it is increasing 0.60. What is the new fringe separation over there? So I will say that it should be taken at 0.90. 0.90 is being taken divided by 2 over there because it is approximately half over there. So it should be taken as it is this is 1.8 millimeter over there. So he is saying fringe separation is 0.8 millimeter. I will have to use this relation 0.60 divided by 0.90. So it is 2 by 3 and 3, 6 and 2, 12. So it is 4.5 millimeter should be there. All right. This was the relation to be used over there. A wire is made from a metal of a constant resistivity. There is a constant current in the wire. Which statement about the potential difference across the wire is correct? Okay. It is directly proportional to length of the wire. Yeah, it's fine. It is directly proportional to length of the wire. Which statement about the potential difference across the wire is correct? Constant resistivity, there is a constant current. So resistance and potential difference are directly proportional to each other. It's fine. Okay, here he is saying IV characteristics are shown for electrical components over there are shown, which obeys the Ohm's law over there. So if I observe the straight line graph over there, then I can say they observe the Ohm's law when the graph is between IV characteristics should be straight line over there. Then we can say it is only done with the number 1 over there because it is never getting the negative value or when the voltage is 0, current is still flowing through it. That is not the characteristic of ohmic device over there. So I should say it should go with only number 1 that the graph is straight line, and if you are giving the negative voltage, then the current is flowing in the negative form. It's fine. But when you say the voltage is zero and current is still flowing, so it is non-ohmic. It is non-ohmic because it is not following the straight line graph over there. Okay. A resistor has resistance this is connected to a supply of 4 volt, and how many electrons enter in the resistor in 4 seconds over there. So first of all, I will have to go for calculation of current. I is equal to V over R, and V over R, V is 4 over 200. So 4 divided by 200 should be taken as 4 divide 200 equals to 0.02, and it is flowing for 4 seconds. Multiply 4 equals to 0.08. Now he is saying this is the ampere current, and he is asking for how many electrons there. So I am just multiplying it, dividing it by 0.08 divided by 1.6, 10 is for minus 19. 0.08 divided by 1.6 times 1.6, then 10 minus 19. I will do what I did. This is the wrong way how to go with it. 0.08 divided by 1.6. 0.08 divided by 1.6 equals to 0.05. So 0.05 will be 5 multiplied 10 raised to power 17 should be taken over there, because it is minus 19 plus 18. 0.05 it was. So option C should be fine for it. Okay, just divide this value 0.08 divided by 1.6 times 10 is per minus 19. You will get 0.05 there. Multiply 10 is per minus 19 should be gone with plus 19. And it is 5 multiplied 10 is to power 17 should be taken over there. Okay, for 35, he is going here. The diagram shows a cell of internal resistance. 1 ohm resistor is connected to a variable resistor. Okay, when the potential difference had an initial resistance 2R, when the variable resistor has initial resistance 2R, the current in I1 is I1, and the terminal potential difference is V1. The variable resistor is now adjusted to a new resistor of 4R. Okay, it is 2 times increased over there. What is the new current of the cell over there? So I will say here, as it is 4 times increased over there. So 2 to 4 and 1 I1 V1 resistance is doubled. So resistance is doubled, then its terminal potential difference will be gone for V1 will be doubled, because you are saying resistance is doubled, then potential difference should also be doubled, and V1 should be doubled according to this point, and current should be half of that one. So option D will be fine for it. I'm not going towards too much calculations involving it, because the video is also going to prolong so much, and I'm just going to mark out the right answers from here. Okay, the diagram shows the 4 terminal resistors over there. Terminal boxes connected to a battery, and 2 ammeters over there. Okay, 2 ammeters are connected, and 1 and 2, and circuit is going to be completed over there. Okay, and he is saying the currents in the 2 circuit, 2 ammeters are identical. Which circuit within the box gives this result? This resistor is being involved. What? This circuit A is not possible, because this is not getting the current to pass between 1 and 2. Not between 1 and 2. Not between 1 and 2 like ammeter is there. So 1 to 3 and 4 to 2. So option D will be fine for it. Only the ammeter A is giving the reading. For 1 to 3 can be taken, and for 2 to 4 can be taken over there. Okay, here he is saying the Kirchhoff's two laws presumes that some quantity is conserved. Kirchhoff's first law and names the quantity conserved. So, first law states that current entering a node is equal to current leaving a node. So, it is the conservation of charge over there, law of conservation of charge, and second one is called law of conservation of energy, where the sum of all voltages in a closed circuit equal to zero. So, algebraic sum of the currents at a junction is equal to zero. Current entering a node and leaving a node is equal to zero. The neutral atoms are isotopes of the same element. Which statement about this is correct? They have different number of neutrons and different number of electrons. No, they have different number of neutrons and same number of protons. It can be correct according to definition of isotopes. They have the same number of neutrons. No, they have the same number of neutrons. No, neutron numbers should always be different over there. Okay, what is the composition of meson over there? So meson is one quark and antiquark is present in case of meson. One quark, two antiquark, that can be hadron, that can be hadron, that can be hadron, because that is made up of at least three quarks are made up of to make hadrons. For mesons and baryons, baryons is taking for three quarks over there and mesons for two quarks over there. A nucleus of carbon-11 has contains 6 proton and 5 neutrons. The nucleus of 11 carbon B positive. So B positive emission hua. So one electron should be decreased in the form of protons should be decreased with its atomic number, and beta positive is emitting over there. Then we will say here up quarks will be 6 up to 12. Okay, because proton are made up of up, down, and neutron are made up of up, down, down. Now he is saying what is the total number of up and down quark in the product of decay of the nucleus. So how many ups are there? 1, 2, 3. 3 up and 5 protons, 5 neutrons. 5, 3, 15 up it should be, and only 16 up. It should be 15 up. 16 up and 17 down quarks should be present just by taking 5 neutrons and 6 proton by beta emission decay. When beta 1 emission is happening, then it means atomic number is going to decrease by 1. So it is 5 protons, 5 neutrons. So 5 protons, 5 neutrons is 15. And 1 neutron is going to come extra because atomic mass is not going to change over there. 1 new neutron is going to be formed, and that should be taken into account. So this was the whole paper. And I think so your basic concepts are being revised and different applications. I tried to explain them. So try to be connected. Kindly subscribe my channel and stay blessed. Thank you so much. Allah Hafiz. Best of luck for your results.